Welcome. We're going to go ahead and I'm going to give you a review over the Chapter 2 worksheet. So if you do not have the Chapter 2 worksheet with you that you filled out, please pause the video and go get it so we can go over it. Okay, let's go over problem 1. I want to make sure you understand that. It says refer to the chart comparison of occupancy classification from the handout section. Remember, I gave you a handout under the content module. Make sure you have all of these handouts put together. So hopefully you have printed them all off, made copies of them, organize yourself. You've got to get organized. So I ask you to look at this particular life safety chart, which is in your textbook. And the chart indicated above lists all the occupancy classifications from the NFPA, which you see right here, NFPA, the Life Safety Code, and then from the International Building Codes. Based on this chart, answer the following questions concerning occupancy classification. It says, if you were asked to design the interior of a prison located in a jurisdiction using the International Building Code, which occupancy classification would you use? Okay, well, we know if we go back and look at the institutional research, institutional restrained, because you are restrained if you're in a prison, okay, that would be I3. You see it right here. Okay? So what you've got to do is you've got to put I3, list I3 down. You can go back and find that, remember, in your IBC code book. You can look at it, but it talks about right here listing where it would be located. In addition, B says using the Life Safety Code, which occupancy classification would you use if you were asked to redesign the interior of a budget hotel? Well, if you go back and look at this same chart and through here, we know that residential, hotels, dormitories, all those, lodging, a room, hotels are considered R, right? So when we look at it, we have a breakdown in ICC, but in the NFPA, it's only broken down into residential. So R would be the correct answer. C. A client asks you to select finishes for a nightclub that he owns. Based on the Life Safety Code, what additional questions would you need to ask your client to determine the correct occupancy classification? Well, first of all, if you're doing a nightclub, a lot of times the main number one thing is the expected number of occupants. Because we know clearly it's going to be an assembly, okay? But if it's less or fewer than 50 people, it wouldn't be. It would be a business. But if you're looking at a nightclub and you've got between 50 and 300 or 301 and 1,000 or over 1,000, it would end up being, of course, an assembly of some sort. So you may want to even ask if you're doing food. Might be another question that you might ask. But what we want to do, it would be assembly, which would be A in the FPA, and it would be A2 in the ICC, and it would be based on the number of occupants. Because if it's below 50, then it would probably be a business. Question D. If you are designing the interior of a large assisted living facility that accommodates 150 residents, and you are using the IBC, which occupancy classification would you use? Okay, institutional, I1. That's because of the number of residents. The IBC uses a number of residents to determine which an assisted living facility is considered an institutional occupancy. Read about the numbers and conditions. When there are more than 16 occupants, not including staff, reside at the facility, it's considered institutional. If it's fewer than 16, okay, down here at the bottom, fewer than 16, not including staff, then it would be considered R4. Right here, R4, because it's talking about care and assisted less than or equal to 16. Okay, E. If you are selecting finishes for the same assisted living using the life safety code, which occupancy classification would you use? Well, if we're using it and it's less than 16, then it would be residential board care, which would be R, so that we'd be able to see that right here. If you're using it, it would be R. Why? It's only appropriate classification. Technically what you would do is you always find out what it is here, and you would look over and see what it is on the other side. So if it was institutional and greater than 16, it would be D1. Detentional correction includes various subconditions. Okay? Now, let's look at problem 2. Now, looking at problem 2, it says refer to the International Building Code Table 1004.1.2. So let's move this book out of the way. And let's go back to our code table. Yeah, I have lots of notes because I always brainstorm and write things on here. So we want to look at table 1004. Let me find it here, 1004. Okay. So on page 241 in the IBC code book, table 1004.1.2, you're going to see where it utilizes this table. It says, based on the table indicated, determine the occupant load for the floor plan that is shown in figure 2.1. The plan is a retail clothing store on the first floor at grade level of a strip mall. Use the occupant load formula to determine the occupant load for the store and write your answer in the space provided. Okay, so the first thing you're going to have to look at is, what is a retail store? That, of course, would be a mercantile. So you would have to come down here to the end and look at mercantile. Okay? And then under mercantile, it's going to give you a few things that you need to look at. So everybody look at mercantile. It's going to say areas on other floors, 60 gross. Basement and grade floor areas, 30 gross. Storage stock shipping areas, 300 gross. So going back to the scenario and when we talked about it, it says that it's on grade floor. So now we've got to use basement and grade floor 30 gross in our scenario. We also need to look at the floor plan. And let's pull out the floor plan here. Here's the floor plan. And you notice that it has the back half, there's storage. So going back here, it says storage stock shipping area 300 gross. So we are going to go through and create a table. And so what you need to do is you need to make sure you understand what the length and the width is, because it's always worked on square footage. So if we have 48 feet 6 inches by the 31, that's going to be your area here, 48 feet 6 inches times 31 feet. Then we're going to go back and create us a table. to be able to look at this. And I always say using this kind of table helps you put things in perspective. So we said we had 48 foot 6 inches, which would be 0.5. 48.5 times 31 equals 1,503 square feet. We know it's 30 gross because remember it's grade level back here, looking at here, grade level 30 gross. So we're going to take the 1503.5 divided by 30 comes up to 50.12. Then we're going to take the storage area. The storage area, of course, is 31 by 14. So we're going to go back, and we know that storage stock areas are 300 gross. We see that here in the table 104.1.2. So we're going to take the 300 gross, we're going to multiply that by 14 times 31, which is 434 square feet. So we'll take the 434 divided by 300 comes up to 1.45. So I'm going to add the 50.12 and the 1.45, and that comes up to 51.57. So I'm going to round it up to 52. So that is our occupant load. That's how we would determine what our occupant load would be for that particular retail space. Okay, now let's look at problem 3. Looking back at the same table, 104.1.2 is asking you to reference that. It says figure 2.2 indicates floor plans of 4 single-story buildings. In which plan could the storage, occupancy, or use be considered an accessory to the main occupancy classification? And write the latter down. So let's look back. Hopefully you've read the chapter because that kind of helps you kind of answer these questions here. Let's look. Because the storage occupancy is less than 10% of the entire building, it would be too large to be considered an incidental room. So let's go back and look at storage area in Plan A. Okay, because B we know is the correct answer. The storage area in Plan A is small enough to be considered a room within the larger room, educational. It is not separate use. This would be considered an incidental use and not an accessory use. Okay? B, which we said is correct because that storage is less than 10% of the entire building. So what you have to do is take this square footage and this square footage, add it up, and then see if it's 10%. So like 10% of 9,125, 10% would be what? 912. But if I add those two together, then that would be less than 10%. Okay? Let's look at C, Plan C. The storage area in Plan C could not be considered an accessory use either. To be considered an accessory use by the codes, the storage area must be less than 10% of the total area. So if we had, of course, 5,100 and 900, that comes up to 6,000 square feet. To be considered an accessory use, the storage area would have to be 10% of 6,000 or 600 square feet. This is bigger. So instead it would be considered a separate occupancy from the A2. That means we would end up having to have probably some type of separation between the two, and they would have to be on their own identity. Then let's look at Plan D. In case of Plan D, the storage S1 use is larger than the factory. This storage, see S1, is much larger than the factory, this cannot be considered accessory use. This would also be considered a mixed occupancy. Okay, let's look at B. Based on the table 104.1.2, determine the total occupant load of the building in Plan A. Okay, here we are back at the educational part of it. The educational E is primarily a classroom. So what would be the answer? The correct answer is 250 square feet. But the occupant load, of course, is determined by the square footage of the space. So if you're looking at this, table 104, we have to come over here and look at educational. An educational classroom area is 20 net. Now, looking at that 20 net, we're going to end up, of course, taking it as 5,000 square feet because it talks about here 5,000 square feet is what's here, and this is 300. Okay? Now, net, there's a difference between net and gross. Net, you're taking the square footage of just the classroom area. If it said gross, you would have to add the two together. But we're just doing net of the classroom area. Okay? So in the table, what you're going to end up having to do is you're going to end up taking occupant load of 5,000 square feet divided by 20 net equals 250 occupants. Remember, we got the net from classroom area, 20 net. So that's how we came up with the correct. We took the 5,000 square feet divided by 20 net is 250 occupants. Notice the load factor used to determine the occupant load of the education area is net. Okay. Okay. The next one is problem 4, and it says refer to table 104.1.2 to kind of figure this out. So let's go through. This is a college building. This is a college building that I gave you this. And of course, I gave you one with seating, fixed seating out here in the middle. And I gave you an occupant load of 20 that was being used here. So it includes in here an assembly, and I gave you concentrated and unconcentrated. There's a library area, and there's administrative offices, and there's a student lounge. Technically, you could take the most restrictive, which would be 171, 35, 15, and the 20, and add them all together to get what the occupant load would be of the building. Okay? But when we look at this, we've got to kind of know a little bit about exits and how things work. And I know we haven't gotten there yet. So I want you to kind of look at how do we figure, of course, the occupant load. I'm going to kind of throw something different at you. If we didn't have this fixed seating in the student lounge, how would we figure our occupant load? So in order to determine the occupant load of the central student area, you must first calculate the occupant load for that particular space and then add the number of occupants from the adjacent areas that have to pass through the student lounge on their way to the final exit. First, determine the occupant load for the student lounge for its particular use. So I've kind of erased mine, not having any seating here. So as a gathering space, it's considered an assembly. You've been told this area is primarily used with tables and chairs, or according to the IBC table 10004.1.2, you use the load factor for assembly, unconcentrated tables and chairs. So if we looked under here, assemblies, okay, unconcentrated tables, chairs is 15 net. You also need to determine the size of the student lounge. We know if we go back that it is 50 by 20. Okay? If you multiply these total up, then this is how you figure out your area. So 50 times 20 is 1,000 square feet. Divided by 15, so if we have some movable tables and chairs, that means it would end up being 66.7, but we're going to round it up to 67. Okay? So let's look at this. So that means we have 67 people right here as an occupant load in this particular area. Now, let's look at the assembly. Now, we don't know how someone is going to utilize an assembly hall or an area, so you always have to figure it to be the most restrictive. That means we have unconcentrated. That means maybe just chairs everywhere lined up. So that means if we're trying to figure our length times our width, which would be 30 times 40, which equals 1,200 square feet, right? And so if we're looking at it here and going back down here to assembly, look at the assembly here at the book. Let me move this here. And if I want to find concentrated chairs only, then I would take that 1,200 divided by 7 net, comes up with what? That's where we got the 171. Okay? I have 171.42. We're not above the 5, so a lot of times you will find jurisdictions will round up, down, but you will find that some, if it's over 0.5 and above, then they round up. So we'll say it's 171 concentrated. Okay? And then if we figured it, the 1,200, and we divided it, of course, into the 15 net tables and chairs, we would come up with 80. So we have to kind of look at it, what is the most restrictive here to be able to utilize that. So we are figuring it at 171. We've got our 171 people that we're dealing with. We have 2 exits to get out of this room. So we're assuming that half of them will go here and the other half will go here. Half of 171 is 86. So I'm going to have 67 plus 86 that may be coming in the student lounge. Now, if I look at the library, remember I have 35 people, but I have an exit to the outside and also have an exit that goes back through the student lounge. So if I'm looking at that, half of 35 is 18. So that means half of them plus 18 may be coming through the student lounge. Now, we notice that we have the administrative offices here. So in the administrative office, 15 people is our occupant load. There is not another exit to the outside or going to through any other space, so all 15 have to, of course, come through here. So what you've got to end up doing is you've got to end up adding your 67, your 86 from the assembly, 18 from the library, and 15 from the offices, so that comes up with 186 people. I hope that kind of clarifies a little bit of that particular one. All right, let's look at problem 5. It says, based on the table indicated above, which is table 104.1.2, indicated, determine the occupant load for the church in the floor plan shown in figure 2.2. Now, this is where we've kind of have to look at it and kind of determine here. Okay, so this is mainly talking about the church. The seating shown consists of continuous wood pews among bolted to the floor shown on the floor plan. So let me get to the floor plan and we'll look at this just a minute so we can kind of understand how this plan is going to work. Okay, so I only have things bolted here. There's nothing bolted on the platform. If we had other bench or something bolted here and something bolted there, it's pretty permanent for the pastor, then we would have to count it. But we're just mainly talking about the pews that you see here. I say in the statement all pews are the same size. They are 14 foot 6 inches long and includes 3-inch wide arms on each side. So how do we figure this? That means we're going to end up taking 6 inches off and we're going to deal with 14 feet. Okay? So to figure 14 feet into inches, we're going to do 14 times 12. That comes up to 168 inches long. Well, we're going to go, it says look at table 104, but it doesn't say anything about churches and how do you go about looking. This is all fixed seating. So I'm going to look over here on the next page, or on the same page down at the bottom, and it says fixed seating. So if you go and you really look hard in here, and it says fixed seating in through here, for areas having fixed seatings without divided arms, move this a little closer so you can see it here. Without divided arms, the occupant load shall not be less than the number of seats based on one person for every 18 inches of seating length. Okay? 18 is kind of a pretty small person to me. I would have a hard time, but so what we're going to end up having to do is we're going to take the 18 and divide it into 168. So that comes up to, so get your calculator out and do 168 divided into 18, 9.3 people. Well, you can't have a 0.3 of a person, so that means we're going to have 9 people per pew. The next thing we're going to do is count how many pews that we have. And you count, there are 16 pews. So we're going to take 16 times 9. So 16 times 9 equals 144. So our occupant load would be 144. So that's how you go about figuring that. Okay, next I gave you, instead of having continuous pews like the first part, I gave you, of course, the scenario of a pew that looked like this, and there was only 8 people sitting on one continuous pew. So here we have the pew, and there's only 8 people because we have divided arms in between. So if I take 8, and we know there's 16 pews, we multiply 8 times 16 equals 128. So our occupant load would be 128. All right, next we're going to look at problem 6. It says a developer purchased a vacant building in an old high school that closed more than 10 years ago. You are working with a team to help the developer determine how to develop the building. Your team has already measured the building. There are 2 floors, each floor with 4,600 square feet for a total of 9,200 gross square feet. Using the occupant load formula and the code table, 104.1.2, okay, using both of those, determine which 3 scenarios would work. Now, the developer, of course, is considered an apartment complex. He wants to divide the building into 4 one-person units. Okay? So if we looked at that, 4 one-person units, so that would be 4. And he wants to do 8 units in through here, 4 people units. So 8 times 4 is 32. and he wants to do 3 units with 6 people. So that's 6 times 3 is 18. So that's a total occupancy of 54. Next, you've got to determine the load factor of this. An apartment complex is considered residential. So I've got to go back to my table 104.1.2, and I've got to look at residential. And residential is right here, and it says 200 gross. Okay? So I've got to go back and look at the formula and use the formula. So let's look at this. I've got it down a couple of ways. 200 gross square feet times 54 occupants is 10,800. Okay? Oops. Messed that up. 10,800. But we have how much? What did I say? We only have 200 gross square feet. So it wouldn't work. But you can sell him on the idea by doing the formula a different way. That's why I said the beauty of codes is being able to go back and explain to your client how things would work. So the occupant load, 9,200 gross square feet, that's the 2 floors. Remember, we have, of course, in through here, 4,600 per floor, which comes up to 9,200. We could divide it by the 200 gross square feet, because that way we know that if we're looking at in through here, our apartments is 200, right? Gross square feet. And so then we could go back and do 200 gross square feet times 54 occupants. Okay, because he wants, let's back up. Sorry about that. So we could take the 200 gross square feet divided by the 200 gross square feet, because that's what we found in the table 104.2. It means we could have 46 occupants. So that indicates then that we could go back and design an apartment complex, but just to occupy 46 people. So that way it might work for them. You can explain to them what can be done. Okay, next, the developers considered turning the building to a retirement center that provides minimum health services. He plans to house 62 tenants and expects 8 full-time employees. Based on the occupant load, will this work? Yes. Okay? Because 8,400 square feet for a retirement center with many occupants is within the 9,200 square feet and allows 75 occupants, and the developer only wants 70. So how did we figure this out? So looking at the table, looking in through here, we had to go through and figure out where it is in the table. Okay, we're looking under institutional area, sleeping areas, and that is 120 gross. Okay? So he says he wants 70 occupants. So if we look at this in the floor area, 120 gross square feet times 70 occupants is 8,400 gross square feet. We have 9,200. So that means that gives him a little room for growth. So you could turn it. Remember, I always say flip the formula a little ways, and then you could sell him on the idea, because that means you have 9,200 gross square feet divided by 120. That is the occupant load factor. Okay, that comes up to 76.6. We round it up to 77. So that indicates how many people could be in the building. So yes, that would work. And he has room for growth. Next, the developer is also considering a 2-story retail center with stores open to the public on both floors. He expects an occupant load of 125 on the first floor and 85 on the second floor. Based on the occupant load, will this work? Well, no, but we could make it work if we made some changes. A retail center, remember, falls under mercantile. So here we are, mercantile, back to where we were to begin with. And it's basement areas, which is grade floors. And then, of course, other floors, areas on other floors, second, third floors, which is 60 gross. So if we're going back and we're looking at this, we have the floor area of 30 gross times 125 occupants, because that's how many he said he wanted to have. And we know the 30 gross is right here at grade level. So if we take 30 times 125, that's 3,750. That works perfect for the first floor because we have 4,200 square feet. But the second floor, if we look at the second floor, areas on other floors, we have to use 60 gross in our formula. So if we do 60 gross times 85 occupants, that comes up to 5,100. Well, that's larger than the area that we have. So how could we salvage this? You know, if you're really wanting the retail area, then we could reverse it. Remember, we could take the 4,600 divided by 60. The first floor would work, but we could take 4,600 divided by 60, and it comes up with 77 occupants. We could give them on the first floor 4,600 divided by 30 and give them 154 occupants. He only wanted 125, but you could have more occupants on the first floor. So therefore, it could work with some modification. But like it is, no, it wouldn't work following the scenario. So I hope this kind of helps you a little bit to understand how this worksheet goes. I hope you listen, re-listen, and kind of comprehend. And if you have further questions, feel free to get in touch with me.